I would immediately come to the questions and would like to start with Sabine on some regulatory perspective. So what do you think, what are the implications of the EU action plan for digitalization of the energy system, research and innovation, and how would you address this in Austria?
Yeah, thank you very much for the question and thank you for the invitation. I think, first of all, I can echo that we really also support the 4Ds of energy transition. We also have implemented these principles in all our R&D policies. In the Ministry of Innovation, yeah, we are responsible for energy R&D. So in my case, for the energy programs and for industrial transformation. And there, of course, all these topics are funded in different R&D programs. So we have the major program is the Energy R&D program. It's located in the Climate and Energy Fund, but since 2 years we are funding it also additionally from the ministry. We have especially for this digitalization, which is it's a cross-cutting topic. It's an own research priority in most of the programs. In energy transition, of course, we have a specific focus on it. But we have other programs where we also see more and more digital projects coming up, like, for example, in the climate neutral cities, in the industrial transformation, or in programs of mobility or heat transition. And that's the national part. And of course, we also are working a lot with international programs. It was mentioned by Angela, the Clean Energy Transition, which is the major one for energy projects, where you can really cooperate with countries, 30 countries, I think. You only need 3 partners from 3 different countries, but it's really a good opportunity, but still there is need to integrate better the Central and European countries because there are lacking, I think, research partners from that side. And we also have IEA programs where you can also cooperate with, I think, more than 50 countries in the world. And there are many in all different energy topics.
Thank you very much. So to continue with Angela, you already touched the legal framework in your talk as well, and Sabine mentioned some challenges ahead. So from your perspective, are the current and planned policies on European and even local level sufficient, or is there anything missing? What would you like to have there if you can choose anything?
Yes, as I already mentioned in my speech, there are many things happening in Europe, and also the European Action Plan is very have high goals, and I think this is very good. But what is missing is that we have to bring this into implementation. So when I talk about my topic, IES, and so we thought we will start a revolution. So we point out a clear methodology, a clear way how to work together, specify together, and so on. And then everything would be interoperable. So that's what we thought. Now it's about 5 or 7 years later, and we don't have the community in the energy sector yet. So what I learned is that we have to take smaller steps, but we have to do them. And I think that is really important also on European level. I'm in the Smart Energy Expert Group from the Commission, and there's so many experts on their topic, and it's so hard to bring them together to develop a clear vision, because everybody sees his own expertise, his own topic is one of the most important, and then it's very hard to get this overall picture. But this is what we will need in the next years, and we have to accelerate this. And there are so many solutions. We can use them. If we combine them, then we can make 2 steps in one approach.
Thank you very much. So you need an energy bridge, you would like to say with it. Okay, then I would like to go to the research point of view now. So, Bharat, you as well, coming back to your talk a bit, so you talked about digital twins, obviously, and that predictive analytics are often mentioned as game changers together with digital twins. So from your perspective, again, how close are we to moving beyond pilots and toward real deployment? And if digital process twins were integrated tomorrow, what immediate benefit would utilities like Burgenland Energie see from that?
Yeah, absolutely. I mean, like I mentioned in my presentation, I think we are at this AI inflection point. So because when we transition from very manual engineers sitting in front of the computer and then crunching numbers and then doing network planning and operation and not bringing in real-time data and getting inputs from all these different sensors that are out there and using them to be able to make better informed decisions, I think that's the turning point. So we should be able to get all this information that's out there and put it into one system, again, single source of truth, and then use this to make decisions. This is going to be far better than what's being currently done right now. Because right now, so utilities, DSOs, TSOs, they only use worst case scenario. So we're leaving out a lot of grid capacity on the table. So we can be integrating a lot more renewable energy. We can be integrating a lot more electric vehicles, heat pumps, so on and so forth, into the current infrastructure already, if we are able to get real-time information and predict and optimize it better. But right now, we're not. So we're only assuming the worst and optimizing the system based on this worst-case scenario. So I think that needs to change immediately, and digital twins and AI can help us do that, to make better decisions.
Very interesting. So I now have to be careful to not get into the discussion working for a TSO, but better continue with Michael at this point of view. So we already heard in the morning from Mr. Enser about the high ambitions in Austria regarding climate goals and decarbonization. And Burgenland is here in Austria, and I think in the whole of Europe, a pioneer as well regarding integration of renewable energies. And so I guess you have already handled quite some challenges through the introduction of such amount of variable renewable energies in your region. And have there already been measures implemented with focus on digitalization, which is our topic here? And are you ready, or are you already doing that you share your experiences with energy suppliers in other regions, and in particular in Central Eastern Europe, which is our focus here? And those might be facing questions you had to answer already, so they could learn a lot from you, I guess.
Okay, good afternoon, ladies and gentlemen. It's a pleasure to be here. Thanks for the invitation. You mentioned at the very beginning we should be energy independent, so-called, by 2030. Yeah, that's the plan, that's the strategy. Whereas independent is a special discussion, maybe, what that means. In particular, I take it as a compliment, actually, that Burgenland Energie has, 150% of its electricity needs covered by its own. Maybe you, from a TSO perspective, see that a little different, maybe, but we actually in Burgenland, at Burgenland Energie, are very proud of this, and of course. Our portfolio at the moment, we have around 1 gigawatt of wind and PV installed at Burgenland Energie. In Burgenland, we have around 2,500 megawatts or 2.5 gigawatts of installed capacity in total, and a maximum load of, let's say, 300 megawatts. So this already implies that there's a lot of need for digitalization. Otherwise, we wouldn't have a chance to feed in all that energy. And yeah, what's the limit actually that we see, or the biggest challenge that we see is the limited grid capacity. We would do more if we could. Yeah, mostly yes, but also, of course, I agree. There's a lot of space for digital improvement, definitely. But this goes in parallel. And but in Burgenland we implemented so-called hybrid parks. So we're coming actually in Burgenland from the wind production side. So we developed our wind park starting from 1997 up to now. So we were only a wind operator first, and now we have a grid capacity for wind, and then we add another double capacity of wind in PV, and now we're adding another amount of BESS storage systems to full hybrid parks. So we have, for example, 100 megawatts of grid capacity, then we have installed there 100 megawatts of wind, 100 megawatts of PV, and then another 100 megawatts of BESS systems. And this implies, of course, that we need a certain amount of digitalization, and the challenges are huge. Definitely. Imagine the controller for the system, for example. It's very, very complex to calculate all the incomes that's coming from the market, from the grid operator, coming from the optimization of the grid. So this is a big challenge. The monitoring is a challenge because the digitalization components that you use are all of different generations. So you need to get that on a certain level. And what I see is the two biggest challenges is the topic of data structure, data quality. Decision making, yes, agree, but from a system security perspective, the data quality is decisive. And of course, we're coming into a power system, so-called democratic energy system, that is a very welcome way, but it also, on the other hand, increases the complexity a lot. And also the topic of cybersecurity is also a very big challenge. That's what we see from our first experience now.
Thank you very much. So I hope we can cover this topic as well in this panel if we have enough time. And now we heard the perspectives from regulatory, we heard the research possibilities, we heard the needs from suppliers, and now I would come to Aleš and ask you, what is Siemens Energy's take on the digitalization of the energy systems, and do you develop tools already to help enabling it? And what is the view of the industry in general regarding the biggest challenges in the optimization of the energy system? And are you actively investing in the integration of AI, for example?
Yeah, thank you very much for the question. I must say I loved the statement so far. I loved also the presentation of Bharat. I think we have very much in common. So in order for this to be a discussion, we need to look at it from a few different angles. But I think, everybody here is completely on one page, that, the challenges to the energy grids are really unprecedented. We have seen so much growth of renewables, and let's face it, nowadays, this has indeed become the most cost-effective way how to add extra capacity to the grid. If you want to build a power plant, I'm not even talking about nuclear plants, but just classical power plants, it takes a long time to do it. So the fastest and the cheapest way is to add renewables. There's definitely no going back from that. What that does, of course, as everybody here also knows, is that it adds a lot of uncertainty into the system, unpredictability into the system. We are getting much more dependent on weather, on being able to predict accurately what the weather forecast looks like. And I will also go back to what you said, Bharat. There is a lot of data out there, but it is in silos. We do not have, so that's why that picture remains with me really very much. The data silos need to be broken down. Regarding, digitalization, I also think if we say now renewables are the answer to the extreme growth of demand, that is the one side of the coin. The other side is also the consumption, because also the consumption has changed a lot. You mentioned heat pumps, electrical cars. We are talking about electrifying everything, and that adds even further to the complexity. So I think, there is just no alternative to digitalization of the power grids and to make use of all of this data. You mentioned artificial intelligence. Yes, of course, artificial intelligence is needed to interpret all of this, but it also adds a little bit to the problem, because artificial intelligence is one of the biggest drivers of consumption nowadays. So it goes actually hand in hand. But all of this happens, in a period of tremendous growth, and then we have, remarkable projects like the Salzburg-Leitung, for example, here, which we all know how long it took to build, and we just don't have the time available in Europe to do that consistently, because we will run out of road, I'm afraid. In the US, for example, where the AI growth is super strong, there are estimates that I think above 2,200 gigawatts cannot be connected to the grid. That's about 2 times the size of the entire grid. The same situation we have in many places. And on the other hand, how old are these networks? You know, in Europe, on average, I heard the other day in the UK, the average age of the transformer is 62 years, right? So, I mean, yes, we also produce very good transformers here in Austria, and yes, they do last that long, but you know, it's not something that you should. So now it's a big boom. It's everybody is trying to find assets to use and to add to the grid. So that's why, coming back to your question, I think digitalization is really the low-hanging fruit. What I see as one of the challenges, however, and that has also been touched upon, is the regulatory environment, because I also think that here Europe needs a lot more courage, because everything is, you know, based on the worst case scenario, and the regulatory bodies will need to make that shift in order to enable guys like you to take maximum use of this technology. Yeah, and that's I think it's an interesting future that we have in front of us for sure.
Thank you. That's a perfect handover to Sabine with the regulatory perspective again, please. And I would like to ask you, are there any specific measures and research priorities, hearing all of that now from the first round of questions, that should be tackled from your perspective, and what could you do to help?
Yes, I can say that maybe all our programs, they are more or less challenge driven. So we don't fix the research topic in advance. We frame it quite open so that the most interesting and the best projects can be funded according to the needs on the market. But I wanna maybe mention some aspects that I haven't heard so much so far. I think it's really key that in Europe we invest more in their own digital technologies, because we are at the moment too much dependent on Chinese and US technologies, and that's really a risk for this critical infrastructure. So all the developments that are in the process, I think they need to come faster to the market and should then also be rolled out and bought. That's also already the second point, that we need to be faster in the scale up, because in the past we did the innovation, then it took some time, and we had some demonstration projects. And for example, for the energy communities, I know it because we financed the first project, pilot project, in the year 2008. So it took more than 10 years, 13 years until this was established really in a law. So now we need really to do everything at the same time, do the research projects, then implement it in a demonstration and fed it directly into the regulatory framework. And for that also we have established in some of the research programs combinations. For example, in the transformation of industry, you can now apply for a research program together with an investment program. So you can get CapEx and R&D OpEx funded at the same time, so that we can support this process from the research to the demonstration. And the third part, I think it will be tackled in the last session, is this user aspect. I think it's also very important that the technology is made for the users and for people, and that this is already considered in the research design, and that's integrated, and that's what we are looking in the project criteria. For example, we really looked at gender aspects in the topic are essential.
Thank you very much. So to come back a bit on the focus of this conference to Central Eastern Europe, and Angela, again back to you. What do you think, how can the European Union ensure equitable access to digital infrastructure across urban and rural regions in CEE? Because it's let's say, easier in digital centers or capitals to have such a change, but in the rural areas it might be even harder? And how does the European Union Action Plan address the unique digitalization challenges faced in these regions and compared to Western Europe? Because already in the last panel, Carol, for example, mentioned that Slovakia is like 5 years behind Austria concerning smart meters and other challenges in that regard. So what's your take on that?
Well, the EU Action Plan shows that talks about common data spaces and consumer empowerment and interoperability standards. So if you make a rollout of digital technology, then doesn't matter where you are located. So in the Central European and Eastern part, they face big challenges like they have old grids and lack of investments, and the EU Action Plan foresees funding for that, but they should invest in standardized technology. So in the same way like we do in the Western European countries. And they can build on our solutions. So in the example of smart meters, the first generation of smart meters were not so smart, but now they developed, and now they can, when we roll out smart meters in Central and Eastern Europe, then they can build on this experience. And we should really take care that these investments follow these standardized solutions. Well, otherwise, they can't participate in digital markets and so on. So we really should think that harmonization on European level is the law there also.
Do you know if this is already happening? Are they talking to each other?
I know how difficult it is on European level. Well, I don't know if they do it already, but we have to try to do this and really show that the investments go in the right direction there.
Okay, thank you very much. So coming back to the research perspective, but I want again talk about technologies, obviously, with you. So what are emerging technologies? What emerging digital technologies are most promising for transforming the energy system after all? And as we all know, and we heard about it in the second panel as well already, the most valuable asset here is data, of course. Mm-hmm. And is there any one major puzzle piece missing for you, which is maybe even from regulatory perspective necessary to facilitate data sharing, which is key, I guess?
Mm-hmm. Yeah, absolutely. I mean, I've already highlighted this in my presentation. I think it's important to break the silos. First of all, cross-border data exchange, especially from the research perspective, because right now it's still not very conducive at the moment. It's difficult to get data from different countries. Because of course, first of all, the network operators are very conservative, and it's valuable data. Of course, they don't want to share this. Yeah, in Austria, for example, AIT is in Austria, so that makes it a bit more easier compared to getting data from a network operator outside of Austria. So we need to somehow break these or reduce these barriers, yeah, in my opinion. So in terms of digitalization, technologies themselves, obviously AI. I mean, there were some, for example, my first local energy community project was called Clue Project. This was in 2018, and I was a coordinator there. And back then, we were pushing for blockchain. That was like a big deal in 2018. And I can definitively say that we will not be pursuing that anymore. The one reason, of course, is because the law of local energy community in Austria really hinders this. There's not really any peer-to-peer market possible because it's energy accounting, at least in the current version of the law. So that's definitely dead in Austria. But I think there's still some interest in some other parts of Europe about this, and that's actually really interesting to see. People are still pursuing this. That's actually great. Yeah, I'm happy about that. But I would say definitely AI is the next big thing. And I really see a lot of advantages with that, for sure. So I hope that answers your question. Or if there were any other specific technologies that you were interested in.
Of course, I would be happy to talk about any technology with you, but I think in looking at the time, it's answered my question.
Right,
yeah,
perfect.
Thank you very much. And so I want to pass over to Michael again. And so we heard about within Austria, it might be easier to get some data for research at least. And so what do you think, how can data sharing between utilities, startups and public institutions like AET be intensified to foster innovation? Because I guess in the end, everybody profits from innovation. And is there something missing in particular from Burgenland Energie's perspective? And have you set any steps already to provide researchers and innovators access to relevant data, or are you a little bit protective of the data?
It's a tricky question for a utility. The second question, maybe first. I mean, yeah, we do have a lot of initiatives with universities, with companies, developers, also startups, and from this perspective, when we want to innovate or develop a product or bring in a new solution, I think to develop this, the data exchange is not the issue actually, because you can more or less portion the data and then or anonymize the data and then work on it. But when it comes to online data, it gets a little bit more tricky, and this is mostly a security problem so far. And coming back to the first part of the question, to foster innovation, I mean, standardization has been said several times already. That's a key issue. From my point of view, also mindset is a big topic. You said smart meters. I was still at the university, when the smart meters came in, the first smart meter generation, and the greatest fear of the users was then the grid operator can see when I'm watching TV and when I switch on my oven, for example. That was the greatest fear at that time. So it's also a mindset, and the data is seen as a proprietary asset, more or less. And when we want to develop the world that we see in the future, this must be more seen as a shared source, more or less, where everybody can profit from. I think it's a soft parameter, but a very important one. And connected to this parameter, I see trust and governance. I think they influence each other, and they need to have clear rules. Who's the owner of the data? What's the utilization of the data? So if you have governance, you can build in trust, and then you more or less reduce the barriers of interconnecting and exchange data. I think this framework has developed in the last years. There's a lot of things still to do, but you have a way better framework than like 5 years ago. So the framework is good, but the solution to really transfer the data then is very individual still. That's a big challenge from my point of view.
Okay, challenges ahead. Thank you very much. Alex, you already grabbed the mic. Very good. So CEE countries are often seen as followers in digital energy transitions, and we also heard that from a member of parliament from Slovakia today. So how can CEE countries change the picture and become leaders, and maybe even leaders in energy innovation rather than followers in the EU digital transition? And do you think that collaboration with other institutions like CETB and Burgenland Energy can accelerate this process?
I would start with basically disagreeing on that, because I think actually the smaller countries featuring in Central and Eastern Europe have a really unique advantage in the sense that they are small, so the systems are a bit less controllable. I'm not going to use the word sandbox, but that is actually exactly what I mean. And to drive that point home, we have actually, as Siemens Energy, seen some of the most innovative solutions and data application cases come out exactly out of these countries. We have had a very, very fruitful cooperation in Croatia. We have signed a bit less than a year ago a strategic cooperation partnership with the TSO in Slovenia, with ALIS, exactly specifically for the purpose of jointly developing new technologies, new solutions. You know, it helps that most of these grids are also quite, I would say, mature in the sense of stability, and they also possess a certain, I would say, reserve. They must be, of course, you cannot try new technologies on grids that are in dire need of investment. But that is certainly one thing. I can also give you a very good example. We have acquired less than a year ago a company that is an Austrian company also, but originally from Slovenia, that is focusing and developing solutions for the dynamic line rating application. And dynamic line rating, I think, is the biggest low-hanging fruit that we have here. They have been developing this solution for like 15 years. And how did they do it? Well, they did it because they were able to test it in collaboration with the local TSO, also in Austria Power Grid, that is the case. So, I think innovativeness is really in the blood of this part of the world. And but when it comes to finding new solutions, I would not say that we are behind other regions. I would actually argue the opposite. So I would encourage everybody to do that.
I'm really glad to hear that, honestly. Very good. So we have still time for a next round of questions. 10 minutes, perfect. So I would like to get a bit into risk and chances of digitalization in particular, and start again with Sabine, if I may. So what do you think, what impact will digital energy systems have on achieving the EU's climate and sustainability goals after all? Will it be a major puzzle piece or just one small among many?
Yeah, thanks for this question. I just wanted to add to the last round, because Bharat did not mention it, on the AI, that we currently also open an AI factory Austria at AIT. That's a big laboratory for learning and testing AI innovations from Austria, and it's open for industry, public, and researchers. And I hope there will be many energy-related AI technologies also developed and tested there. Yes, concerning the digital systems, of course, as it was mentioned during the day, this is a great enabler for the climate goals. But what we have seen in the past, we already heard it in other presentations, that also on the EU level, we had very different pillars, and they were not coordinated very well. So we had the Green Deal with all the different elements, but we lost a little bit the competitiveness area. So it was not really linked to it, and now we see that we are losing competitiveness, and there are the discussions that this need to be changed for the next framework program, that all the different policies need to be linked better together, like education policy, innovation, but then also the industrial policies, and also, the qualification side. And yes, that's the discussion going on the European level, that really the framework program and the EU competitiveness fund and the industrial policy will be integrated. And that we still follow the climate goals, but also don't lose sight on the competitiveness.
Okay, thank you very much. It's for sure important to keep competitive. And Angela, so another big chance, I think, and it was mentioned today with energy communities and such things. So how can digitalization empower consumers to actively participate in energy markets, like being prosumers, providing demand response and such stuff? And we don't really have to get deep into the topic, but I think it's also a very interesting topic. How can digital tools help to reduce energy poverty and improve energy access in underserved communities, probably?
Well, consumers can profit from digitalization because there are many new tools and so on, but they have to be interoperable, because consumers don't want to, they want to have plug and play tools and not install drivers from anywhere like we did 20 years ago. So if a consumer has a PV and the storage and then EV, electric vehicle, for instance, they need to be able to talk together. Otherwise, he can just use it like we did it with fossil cars, for instance. So we really have to look that we can provide solutions that are harmonized together, that have platforms which can share data, and then we open the access to new market models like this demand response and peer-to-peer trading and so on. So this I think we have to do, the legal framework, the technology providers, we really have to look to provide those assets in an interoperable way. And for vulnerable households, if they have low threshold access to those tools, then we can provide solutions for them to make their consumption visible and so on. So they have already some tools to work on this, and if they are able to participate, for instance, in energy communities because they have a smart meter and so on, then there can be solutions where we can help them without many other efforts.
Okay, thank you very much. Interesting. And to finally address the elephant in the room, I guess, which is data security, cybersecurity.
Yeah, right.
And you're not the elephant in the room, but there is, of course, an extensive exchange of data and ongoing out there, and progressing digitalization peers increased cybersecurity risks. So what are the main threats, or maybe the two main threats from your perspective to data security associated with digitalizing energy systems? And what do you think, how can they be mitigated so people trust into data transfers?
Right. Elephant is my favorite animal, so yeah, I don't mind. So I think I want to highlight, especially you're from APG, grid operator. I think it was also mentioned by Sabine earlier. One of the very important, how should I put this? A security concern would be this massive amount of photovoltaic installations across Europe, which is reaching significant amount of share of our energy share in Europe, and all of these are manufactured in a different country, and we don't have control over these devices. So the spinning reserve of Europe is approximately 3 gigawatts, and we have 10 times that amount of photovoltaic installed in Europe. And cybersecurity is extremely important in this situation. And do you know the most famous password for all these inverters that is connected there? 0000. So I think it's a huge vulnerability that we are currently, I think, ignoring, in my opinion. So we should definitely put high focus on this issue and try to get control of all these distributed inverter-based devices that are across Europe. And it's directly linked to the inertia of Europe. The spinning reserve is 3 gigawatts. We can lose one nuclear power plant in Europe and still be connected, and then the frequency is still stable. But just imagine that there is a cyber attack on all of these inverters, and then everything turns off. We cannot recover from this. So there's going to be a continental blackout. Yeah, I think this is super important. That's why I want to highlight this. And of course, I want to echo what Sabina mentioned about the AI factory. So we also welcome all of you to submit to this and be part of it. Yeah, but that's one of the biggest vulnerabilities that we face right now.
So how do we get people to change their passwords from 000?
I think this is directly linked to what Angela just mentioned. So everything needs to be automated. So this is one additional step is too much for a lot of people. So this needs to be inherently integrated into what we sell on the European market. So there needs to be a very strict regulation on cybersecurity and make sure that this is somehow already integrated. So the manufacturers need to put this in their devices already so that it's safe for everybody. And then there should not be another step where people go and change the password.
Yeah, good point. I mean, for the Wi-Fi, that's the case, for example. Yeah. But that's more important, obviously, to people, that nobody connects to their Wi-Fi. Yeah.
For sure.
So, Michael, I would like to continue with you. What are the key barriers to creating interoperable and secure data ecosystems in the energy sector? What measures have been set by Burgenland Energie, for example, to locally ensure your data security, if you're allowed to share that information?
of course, at a certain level. But let me get back on this. Of course, the democratization of the energy system has also its risks in cybersecurity. We need to face that, but not with fear, but more with just being aware of that. That happened all the time, and it still happens, and I think that's what we should care about. I don't know if somebody in here knows the 50.2 hertz problem of PV, starting 2000, around 2000, yeah, where they had a normative regulation where they said PV should disconnect immediately at the frequency of 50.2 hertz or 49.8 hertz automatically, because there were just a few PV assets in the grid, so that doesn't really matter. And with this regulation, the first PV increase up to 2010, 2012 went into the grid, and we had gigawatts. In Europe, 30, 40 gigawatts of PV installed with this characteristic. So if the frequency would have gone to 50.2 hertz, you would have lost gigawatts, 10, 15, 20 gigawatts of that power with a primary regulation reserve of 3 gigawatts. So then now another bad news, the biggest power plant in Austria is not controllable. Controllable in a way from a system security point of view, PV again. So we have more than 9 gigawatts of PV installed at the moment. 80% of these are not controllable from a security point of view. So that's not good news. And then electric vehicles, they coming into the grid, how do they react when you have a blackout and the grid power is coming back? How do they react? That's crucial for getting a stable grid restoration. So these are things actually that we should just be aware of, and we should think of when we bring in thousands of units, digital units, what is the system need for them, and what is the effect when something goes wrong. I know there's always, the utilities are very conservative and they are very on the brake, but still they have their system security somewhere in mind, and that's what breaks them a little. But I think it's a good balance if you have the progressive way of innovation, and on the other side you have the utilities who are taking care of the overall security. I think in the last years we have done a good job in Europe so far.
That's very positive. Thank you for that. And so for the last question to Aleš, how does a fully digitalized energy system in CEE would look like by 2030, which is in 5 years already? And what milestones must be achieved to get there? So what will be maybe the contribution of Siemens Energy in achieving this vision? And please a short answer, because somebody's getting nervous over that.
I think my colleagues touched many of these points already, but I think crucial is, there are different starting points to getting there. So the first thing that needs to happen is, it was mentioned, standardization. And making as much use of the data as we can. I wish in 2030 we will indeed have a fully digitalized energy system, not just in terms of putting it to better use, as we have heard, but definitely also in terms of system reliability and security, because all of these assets are under immense strain, and we really, really are working towards achieving a transparency of the assets installed for TSOs, so they can be, reliably used, and also, last but not least, that they can be tested virtually under different stress conditions, so that we cover all of the scenarios in a digital manner, and ensuring that the physical system remains stable. I think that is key, and I wish in 5 years we're all going to say, yeah, good job. Thanks.
Thank you very much to all of the panelists. It was a great discussion, very interesting for me as well. Thank you.